So it is
No
my
worries.
pleasure to introduce Jeff Glatsein, our webinar speaker today. Jeff is the Senior Manager of Cyberinfrastructure at Woods Hole Oceanographic Institute, where he oversees data systems for the Ocean Observatories Initiative. And today he'll be speaking to us about data delivery user experience. So go ahead and take it away, Jeff.
Thank you. It's my pleasure being here. Good afternoon, morning, evening, wherever you're located. In my role as Senior Manager, I'm also responsible for all data delivery, as well as the software delivery. And full disclosure, my background is not science, it's in software engineering. So a lot of this will be flavored by that. I'm really happy to talk about this. The user experience has been a passion of mine for a while. I did take user experience training a while ago. It may not be relevant anymore because it was over a decade, but it's something that I've used in terms of design. I won't be so much talking about user experience design. That's a whole different webinar that could take a very long time. But I did want to talk about user experience as we see it at OI. So the goals are, why did we focus on user experience? How did we identify that we might have an issue? And then how did we fix that issue? How did we research and implement changes? How did we determine that user sentiment was off or on or what it had? We're also going to show a before and after data portal approaches. And I say sort of because our legacy portal really doesn't exist the way it did when we had issues. We were able to take some low-hanging fruit, and I'll demonstrate that. But I want this to be a back and forth discussion. So I want to hear from the user community, your community and your facility. What does user experience mean to you? How is it perceived? Is it important? Is it measured? If so, how? And was it a consideration during your development process? So what is user experience? I asked Wikipedia, the authority on everything. And basically, it's how a user interacts with the experience, the product, the system, or the service. I love this sentence. It includes a person's perceptions of utility, ease of use, and efficiency. The key word there being perceptions. We had a lot of perceptions to deal with. Some were accurate, some were not as accurate as we'd like them to be. How it pertained to OI, we really care. How easy is it for the user to find that data? You really have to, you can apply FAIR principles here. How findable is the data? But once you find it, is it easy to retrieve? Does it perform well in the retrieval? It takes you days to get the data. Well, that's great, you found it, but now you have to get it. And then once you have it, is it understandable? So these are sort of the things I'm looking for as what does this mean to your facility as well? A little bit about OI. So we have a few setup screens here. We serve real-time data, 900 instruments on 80 platforms, 5 arrays in the water now, but as you can see, the yellow squares and circles here, we do store data because we've had platforms in the southern hemisphere, and we've moved platforms, but we still store and serve that data. I think what's really important here is we're served by United Cyber Infrastructure. So everyone delivers what we call MIOs, Marine Implementing Organizations. That data is delivered into a central location. The data is freely available online. And we have a 30-year lifetime. And right now we're about 10 years into it. Some of the other universities involved. So Woods Hole has the PMO. I sit in the program management office, the PMO. They also put instruments in the water, mostly in the Atlantic with one in the Gulf of Alaska. University of Washington has a cabled array off the coast of Oregon, and Oregon State has a uncabled array. And you get a flavor for what they look like here. It's not just one array, it's many sites within an array contains many sites, and the majority of the instrumentation we'll see are under the water. So I want to give you an idea. This is a nice shot. The picture on the left is a video of a camera that is pointed at a hydrothermal vent because we do monitor a active volcano, which I think people are starting to bet when it will go and erupt here shortly, as well as that's our Erminger Sea. And you can see that there's a mooring taking measurements at the surface and in the air. But what's happening below that is there's quite a few instruments that are moving up and down in there. So that's one of our more challenging environments. Our mission, and this is important to keep in mind, we do not conduct research. We provide data, research quality data to the community. So there are some limits to what we're allowed to do with the data. And on the right here, you have some of the variables that we present, and this will be important when I show the data. This is just a subset. We have a fair number of variables, and that also kind of affected user experience, because if you're not familiar with us, you may not know everything that's available. I'll show you how we solve that. And we monitor an active volcano. So by the numbers, so this is what the data that we manage across the 900 instances. Currently, we have about 175 billion rows. This data is maybe 3 months old. 2.8 petabytes of raw data, and raw data does have its purpose. There are people who would prefer the raw data over the processed data, depending on their area of interest. Close to 13,000 hours of video. Think about that. How do you can't download all of it. How do you process that? 2.1 million digital still pictures. Kind of the same issue with video. And then, of course, 400 hours of hydrophone acoustic sampling. Again, that same issue. Data delivered last quarter. As you can see, we do get a fair number of requests, and we move a fair amount of data out there. So we need to be performant. That's an equation that's part of the user experience, not necessarily all look and feel. So a little bit about our timeline. The PMO that I'm part of is the operations PMO. So we started in 2018. I started in July, and around August, we started to suspect that there was a user experience gap. And I'll talk about how we detected that. By the next year, 2019, we had already done an analysis of alternatives, and vendors were identified, and they started the next project year, which was that coming October. And just shy of a year, a little less than a year, we had a new interface stood up. So we really tackled this very seriously and very quickly. Some of our technology and use, I think this is important to keep in mind, and some of these are newer as part of the solution to user experience. But our Cassandra and Postgres databases, while fine, is something we inherited. We had to keep that. But we've added Kafka, Jupyter Hub, and Grafana, and a deeper use of GitLabs to help close some of the gaps here. And I like this slide. We've since redesigned our data center. So this is 1 generation old, but I wanted to present it because this is a data center that really helped with the user experience. So it wasn't only a software implementation and a bit of a change of mindset. We also needed the hardware to back it up, as I just talked about performance. So it's a pretty beefy environment with 896 cores, a fair amount of storage, and most importantly, a lot of RAM and speed between the switches. That the 25100 gigabyte power switch really was key here. So how do you get that data out of OOI? And this is the crux of it, right? So our legacy portal, OOINet, which we call the data portal, when you go in there, and I'll show it to you a little bit later, it's an on-demand plotting and data delivery tool. On-demand meaning when you ask for data X, it assembles it. And there's some steps to assembling it, such as applying calibrations, QA, QC, those sorts of things. We also have an M2M, which stands for machine-to-machine API. For those that know what they want, they don't really need to go through the UI. You can actually ask for the data to come back, and that's also on demand. And I don't see that particular service ever changing. It's very useful. And then we have an Apache file interface where you can browse for the instrumentation raw data files. A little bit ugly, but servable. It basically looks like what your file share looks like on your laptop. with folders, etc. Since the UX analysis and actions, we've added tools. We have our new UI, which is Data Explorer, which is tuned for data exploration. And we're changing our mindset to pre-generated data plots. Direct access to all our pre-computed data sets now. So you can go right out to our thread server and pull all the data. Again, if you know what you want and you've been an M2M user in the past, you might want to just go out to our thread server and download what you need. We now have direct access to raw data, including that video and sound, using Jupyter Hub. And Jupyter Hub also has access to our process data files and our raw data files. So you could come into our environment, and this is our next level user experience. You come into our environment, use our CPU, use our equipment, and do your analysis. We also have an ERDAP server. Please don't ask me what ERDAP stands for. It's been lost to time, but that's also an API. While it's not maybe the best looking, it kind of looks like it was written in the 90s. It's extraordinarily simple and very effective UI, and users in the oceanographic community really do like it. So how do we know that we had a problem? Most of it at the beginning was anecdotal. When I started, the first thing I did was I talked to people inside the program. I got to talk to people outside the program. And I started to hear stories of, well, we held this workshop and we couldn't get the data out after the first 10 minutes of trying. People didn't know how to use the UI and so forth. And there were people at Woods Hole who also introduced themselves to me. So the occasional interaction with scientists outside of the program as well. We also have measurable data. So it wasn't all just anecdotal. I was able to see that it took a while to get data out of our system. Some of it was as simple as doing wall clock measurements, but some of it was also looking at the database and seeing what queries were a problem. So what we decided to do early on, we were a young PMO, we decided to do a self-analysis report. What are we doing well? What aren't we doing well? And that's what you see here. You know, we had 5 categories. We used Harvey balls, those ideograms that you probably remember from Consumers Report, as a visual indicator. And you can see some things we're doing okay, other things not so well, and then some things we're doing very well, such as data is available and it's reliable. Our hardware, while we weren't necessarily performant, and that wasn't all the hardware issues, some of that was software, it had some very good uptime. We had a large breadth of data. It was mostly easy to enter into the system, and it's available on a timely basis for the most part. But it wasn't easy to find if you look at here. So part of this analysis was we conducted more formal interviews inside and outside the program. I wanted to get away from that water cooler. And we also gathered data from historical documentation on requirements versus features. So it was a little bit of an archaeological search, as well as talking to people. And for me, talking to people, I think that is the best way. And that's where that perception comes in. So you're getting a lot of people's perceptions. And as I like to say, their perception is our reality. So that led to a process of an analysis of alternatives. And I don't expect you to make sense of this very long spreadsheet, but that is what we use to determine some architecture possibilities. And we entered our own software in here, and we rated it as well next to other solutions. So we took the gaps that were identified in that self-analysis report, and we sought out solutions, either purchased, developed. The goal was to solve the gap. So that's that detailed report. The worksheet has 8 categories, 57 features or functions is what came up, and we brought together, and I know it's the last bullet point here, but we brought together a working group, and it was the working group that put this together from their perspective, and we had a diverse perspective there purposely. And so each of the category was weighted, and then the feature within that category was weighted. So we get a good idea, because there were a lot of gaps. This is covering a lot of territory. There's some territory that a solution may not cover. What we did do here, you'll see the red. Red was a must. If there was a low score in a red box, it usually meant that whatever that solution was, it wasn't going to be viable. Orange was strongly desired, and then the rest were nice to haves. If you go through this, we didn't necessarily have one item that said, hey, user experience. But if you look at it, the user experience, anything that dealt with user experience added up to about 30%, which was the largest category here. And we also had to take practical things into account, such as budget, how is it going to be supported, did we understand the technology, those sorts of things. And that was outside the user experience. But members of the research working group were both internal and external. They weren't all internal to the OOI program. We had software engineers on that, data specialists, scientists. We even had some external governance members in there, and our external governance are users as well, and they are scientists within the community. So what did we find out? I have to tell you, they were surprised. The results were very much a surprise in some cases and not as much in others. But we found that our data delivery mission was more unique architecturally than expected. No, we didn't expect to find a lot of oceanographic data transformation tools out there, but what we did expect was to find data transformation tools that could handle data. I mean, oceanographic data it's numeric, so it's not necessarily, for the most part, not necessarily that different, but it limited the choices of technology partner. Here's one of those perceptions that we kind of broke through. The back end, the data management software, was fixable and not in need of replacement as was previously thought. We were able to identify the fixes, and they were within our core skill set. So we took that on as, okay, well, let's fix the system and let's move away from a one code base solution to a best of breed approach. User experience was deemed to be the most impactful change. To improve the user's experience in finding, retrieving data, I mentioned this earlier, we really did need that paradigm shift and kind of do that 180-degree here. And so we moved to a pre-calculated model. We also downplayed. We had a lot of, I think people would call it jargon. It's meaningful to us, but not so much to people who may be new to OOI. So we de-emphasize that for more common terms. We decided that plots would be the main method of data exploration. And while this isn't a huge change because our original tool did do data plotting, you'll see what I mean when I go into a demo. We implemented a more robust search feature. Again, both UIs have search. It's where we placed it. That's the big difference. And then we used a user-driven project management approach. By that, we went out, we talked to users. How do you access data? What do you expect of the data? And we created user stories. And then we implemented those user stories over the year. Are you an instructor? Are you a researcher? Well, if you're a researcher, what data do you look at? How do you bring it down? How do you process it? What are you looking for in terms of what level that data should be set at? How much processing should have happened? And through all of this, we ended up selecting Axiom Data Science as to implement our new UI. And they had a lot of work in this area, if you know them. So a lot of the user experience training that I talked about earlier, they had already put in to some of their UI. So we got to take advantage of that. So let's go. Live demos are always risky, but let's give it a shot. You should be able to see OINet now.
Yes, that works.
Yeah. Okay, so as you go through these, you will see they light up. And that's fine. And the two interfaces are very similar that way. So I am going to go to Global Southern Ocean. And this takes you to a screen. Now, in theory, you could go directly to data through this, but I'm going to walk it through the way I think a user might. They know that they want the Southern Ocean, and they have different moorings out there, but not quite sure what those mean. So I'm just going to go to data access and plotting. And so you get this screen. And you could apply filters here if you want, but again, it's a little bit of interior our nomenclature. The big change that we made was this reference designator, which identifies an actual instrument. Used to be very primary here. We moved it off to the side and we changed some of the language. I'm going to go into, and I want to select a CTD because I want to look at temperature. So I hit plus, and it fetches stream. And I think this is where the user experience you'll see is a little bit different in that you now have to make some choices between here. Do I want recovered host? Do I want recovered instrument, telemeter? What does that mean? And then what are these tabs here? So I'm going to pick recovered instrument. What do I do now? Well, if you were paying attention, you'll see that these suddenly highlighted. So I can go to plotting. And now I can plot. Always do time versus stop temperature and plot. And so now it's thinking. It's calculating the plot on the fly. It didn't take too long. This is a very light data set. If I used a more complicated data set, that could take a little while. And you can see the seawater, and we can play with this. But I want to take you up here. This is actually, since I can't do them side by side, thanks to Zoom, this is only a week's worth of data. That was one of our performance issues. The interface defaulted to all data. And that would have been okay for the CTD, but for some of our bigger data sets, particularly up at the cabled array, which produces data very quickly, that could take an hour to come back with that query. And if you're in a workshop and everybody hits enter at the same time, that's part of the issue that we had. So we actually made a software change to make it so that you only get a small amount of data to look at, and then you could pick how long. So people who are used to working with the system know to go up there and change the sample. You can also do different plot types, plot styles. Now you'll see that we have a lot more data. We have an area where data was not delivered. Keep that in mind because I'm going to show that differently in the next demo. And you get some information such as how to bring this in if I want to go through the API or bring the data in directly. We give a hint on how to do this through curl or through Python. So we give some hints there. Let's say I want to look at another. So this was 500 meters. Okay, let me look at 1700 or something. How do I get there? Well, I have to come back to data navigation. I have to unselect the data, and then say, okay, well, and then go through it again, the exact same way. And I don't need to repeat that. So functional, but I think there was room. The team felt there was room for improvement on that. So let me stop the share and bring up the stream engine for this. You should now see them side by side. Oh, no, you should now see the Data Explorer on there. I've got a nice green box on that. So we moved a lot of those search terms and the navigation up front. You can enter any search term. I could type in temperature, I could type in video, and all of our video assets will come up. But I'm going to kind of come through and it'll work the same here as it did in OOINet. You can move the globe. You can see where do I want. I'm going to pick Southern Global Ocean here. We know we wanted CTD, but well, what else is out there? It tells you right up front what your assets are. It tells you for Global Southern Ocean, what does that array measure out there through what instruments are on that. And then it goes through and it tells you all the parameters that are available. So you don't have to know what the parameter is. You have temperature, that's great, but you see there's 1, 2, 3, 4 temperatures. We want water temperature. We don't necessarily want air temperature here. So you don't have to guess here. And so I'm going to pick CTD. I'm going to hit go. And this is what I mean by we're going to do data discovery through plots. So this is pre-calculated data. And now you can look at that 180 meter CTD, that 250 meter. You've got conductivity. And well, these are both conductivity. So now I'm getting conductivity, which last time I did this, temperature came up first. Well, I'm not really that interested in conductivity. So let me just narrow it down to temperature. And here you now have your temperature throughout there. And then, we can just drill into this. And here's what you see with the data. You get seasonal statistics. If you don't like them, turn them off. This is our data availability. If you remember the prior one, that was a bar underneath where you had to select what your delivery method was. Here you don't have to do that. We've combined it. And here's that data gap we were talking about as well. And you can drill in. You do that on the other product as well. But here you can manipulate it a little bit more. The one big difference that our legacy software had that this doesn't is you could do multiple, like I could put conductivity and temperature on the same plot. It's a little more complicated with this one, but really our goal for this is data discovery. We want folks to know where the data is, at what depth is it. So you'll see the depth come out. And while I did click on CTD, maybe I'm more interested in dissolved oxygen out there. So, or wow, there's a bioacoustic sonar. So really the user experience was more about bringing forward, in this particular case, some features and functions and eliminating some of the clicks and really addressing a user who maybe isn't as familiar with us. That was really the goal. If you're familiar with us, this interface is perfectly fine. It does quite a few things. It's not. I don't want to speak ill of the legacy interface. It's fine, but this one had a very different mission associated with it. I'm going to try to get back into presentation. So the UX changes have been positively received. How do we know that? We ran surveys. Well, our governance body ran surveys. We had surveys, got to mention, from the legacy as well. It was a huge turnaround. It was very positive feedback. We also held town hall meetings with users, and we got very positive feedback in there. Our user questions have changed to be more specific and less general. In other words, not how do I find, we're starting to get, I don't think this data in this particular time frame is right, or how do you process X, Y, or Z? But there's still plenty to do. We continue to tune and tweak the UI for improvements. Our 1.0 of that new solution, people had a hard time with the data download facility. You should download the data as you see it, or you could download the full data set. If you've drilled into a certain time frame, you can download that. But if you want from beginning to end, you have to go to a different, ask for a different file. That wasn't clear. We made it clearer, and I think we still have some work to do there. We're considering putting in more search terms. Right now, our search terms really are driven by a lot of our metadata. But what we don't have as our metadata is maybe how we think as users, such as instead of temperature, biochemical. What do you have that's biochemical? What do you have that's meteorological? So we're really looking to tie in our science themes as broader terms. And we've got that feedback from a user. I think it's a great idea. We also continue to address other user experience areas. I talked about this earlier. So we've got 175 billion rows of data. You saw the millions of photos and thousands of hours of video. We're 10 years into this. We're only 33% through. So we're going to have constant data growth. And because of that, we will definitely have pressure on performance, particularly download. To download some of the data, like what I just showed you, temperature, will probably never get to be that big. But if you want the 30-year, within the oceanographic community, decadal type of studies are very important. That performance will start to erode over time. And we know this, which is why we put that Jupyter Hub that I talked about in. And now you can attach directly to the data. I think there will still be times where you want to download the data, but you don't really have to wait to get started. And then the big question, what to do with the legacy UI? So I've talked about how we've solved some basic problems, yet there's still a core of our users, and we know this from surveys, that really like and prefer OOINet for many reasons. So the fact that it's probably easier to put two distinct measures on there to look at them side by side, and probably some familiarity as well. So we do have to figure out what to do with that. So we really don't want to necessarily maintain two UIs. So I've left plenty of time. I did this on purpose. So I've walked through our experience. Why we focused on this, because we felt that through surveys and anecdotal, along with some hardcore evidence, that it was a barrier to entry to use our data. And we felt really it was a little bit of survival to fix it. How are they identified? We did that self-analysis. We did the analysis of alternatives and identified and implemented some changes. UX wasn't the only thing, but it's not necessarily worth going to the other stuff. It's a different webinar. How did we determine user sentiment? I'd love to say it was highly scientific. Not really. It's mostly through surveys and talking to people, holding town halls, one-on-one interviews, both before and after the new UI was implemented. And we viewed, not as well as I would have liked, but we viewed the before and after data portals. I learned something new about Zoom today. So what I'd really love to hear is some of your feedback. What does it, getting back to the questions that I originally posted, what does user experience mean at your facility? Is it perceived as important? Is it measured? I'd love to know how. And was it considered during development? And I'll open it up for questions.
Okay, well, thank you so much, Jeff. And we'll see you guys at the next one.
Great. Thank you all for listening.
Thanks, Jeff. This was great. Thank you.